days on lesson 5.2 right now, and then we're going to spend the block day reviewing quite a bit because we'll have like an entire class period essentially to review and then some, because you're just taking a quiz at the end of it. So we'll spend a lot of time reviewing on, when do I see you guys? Thursday. And then at the end of Thursday's class period, we'll take a quiz over it. Those are usually the best quiz days because you've seen it and it's fresh and it's all like in your brain ready to go. And then you take the quiz on it and you nail it. So hopefully that's the case today. What we're going to do right now is talk about substitution. And I think you guys touched on this at the end of the year last year. Do you remember doing substitution at the end of the year with Mr. Lever? Okay. Who's an athlete in here? What do you play, John? Baseball. What do you play? Track and cross country. Okay. If we're talking sports, if we're talking baseball or track, let's say track. Let's say the 4x100 is going to run. Oh, this is like the Olympics. This happened this year. Noah, what was his last name? Lyles. Noah Lyles was supposed to run a relay, and then he got COVID and got sick or something, or I don't know what happened. So they had to substitute someone in his spot. Now, when you make a substitution like that, what are you hoping is true about the person coming in? They're as good as the person that went out, right? Because you probably have your best there. So when you substitute someone else in, you want them to be the best too. You want them to be equal in value. You wish they could run the same race. Or if you take a pitcher out, you're not going to substitute them for a shortstop, right? You're going to substitute a pitcher for a pitcher or a center fielder for a center fielder. So that's what I need you to think about as you think substitution, is we need things to be equal in value, okay? Okay, so here's just the words you're going to write down for me, and I will take my time giving you the time to write this down. But the substitution method of solving a system is this. It is solving systems of equations by substituting equations within one another. Solving systems of equations by substituting equations within one another. So within each other, taking something out and putting something of equal value back in. If you think of like a classroom, I feel like this is hard to do because they're not trained like your classroom teacher is trained. But if I have a substitute, we're trying to find someone who can do what I did in that same class period, right? It's a little trickier there than in baseball, maybe. Okay, so there are going to be 3 steps for how to solve this. And you'll hear me say this first one a lot. But the first thing you're going to do is you're going to solve one equation for x or y. And the word you're going to hear me say over and over and over again is isolate. Okay, the idea is isolate a variable, get x by itself or get y completely by itself. Okay, so you're going to solve one of your equations either for x or for y, and it doesn't matter which one, they'll work perfectly well either way. Step 2 is you're going to substitute that expression into the other equation, and then you're going to solve for the other variable or the other letter, right? Variable is a letter. So isolate first, then we substitute. Hello, Sanaya. The third thing that you're going to do, thank you, ma'am, is you are going to substitute again. Okay, you're going to substitute your answer into the equation, the new equation from step 1, or I'm not picky about that. You can substitute it in a couple places I'll show you, and solve for the other variable. Okay, so this first one is probably, I don't know, in my head it's the easiest one, but maybe it's not the easiest in your head. Notice the format of these first two, okay? It says y equals 4x minus 1 and y equals 2x minus 5. So when we're doing substitution, step 1 is always solve for x or solve for y. Well, what you notice here is both of these have been solved for y. So you don't have to do that step. It's already isolated. It's already by itself. The beautiful thing is if I know what y equals, okay? So I know that y is the same as 4x minus 1. I have a y right here. So I'm going to substitute in place of my y a 4x minus 1 because I know they're equal in value, okay? So what this looks like is I take that 4x minus 1 and replace the y. What does that equal? What's on the other side of this equal sign? 2x minus 5. Okay, that is substitution. I took out the y and I put in the 4x minus 1 that I know it equals. Okay, now from here, it's do the algebra. And this is what you guys practiced a whole lot of last semester or last year, is just how to solve this. How do I solve when there's an x on either side of my equal sign? What's my first step? What? I would say combining like terms is when they're on the same side of an equal sign. So I know what you're saying. I just am not going to call that combining like terms. I'm going to say bring my terms together, maybe. So I'm going to move this 2x away from this side. 2x minus 2x is 0, but whatever you do to one side, you have to do to the other. So if I'm subtracting 2x on the right, what do I got to do on the left? Subtract 2x. Okay. I like to do just one big subtraction bar here. So 4x minus 2x is 2x minus 1 equals negative 5. What's your next move? Get rid of the 1. How do we do that? You add it. Yep. Add the 1 to both sides. If negatives throw you off at all, please don't hesitate, God bless you, to use your calculator. I let you use your calculator all the time in this class. If you want to plug in negative 5 plus 1, that's totally fine, okay? You get 2x equals, what is negative 5 plus 1? Negative 4, okay? And then you have one last step to get your x. What is it? Divide. So you get x equals negative 2. Okay, now here's the deal. This is where I feel like a lot of people stop because we got to this place of x equals something, okay? The issue is that's not our answer. Do you know what we have to do from here? Plug it in to get what? We got to get the y value, okay? So we're going to take that negative 2. Now here's what the directions up top say, plug it into the original. You can plug this into either of the two equations. So I can plug a negative 2 in here, or I can plug a negative 2 in here. Which one do you want to do? Top one? Oh, well, you can both do it differently. I'm going to plug it into the top one for now. So 4 times a negative 2 minus 1. Okay, that negative 2 is this negative 2 that we found. So simplify that. Y equals negative 8 minus 1. So y is negative 9. Now think back for me. The first 2 days of class, we did graphing. And when we graphed a system, what was our answer? A coordinate, a point, right? It's where they met up. So if I have a graph, this is my solution, which on a coordinate plane is a point. So yes, your answer is x is -2 and y is -9. Maybe a better answer is -2, -9, where my x value is -2 and my y value is -9. Okay, so that point is where the graph of those two equations would meet up. Does that make sense? Okay. Any questions on that one? All right, look at number 2. If you go back to the directions, step 1 says solve one equation for x or for y. Are either one of these equations solved for x or y? The top one is. The top one has y by itself. So we know what y equals. Y equals 6x. Now look at the bottom equation. 2x plus 3y equals -20. Where can I put 6x? Where the y is, right? We're substituting for y. The y is here, so we're gonna take that 6x and we're gonna drop it in so that we only have one variable. That's the goal. Get rid of a variable, because you can't solve when there's two variables, but if there's just one, you absolutely can. So I'm gonna go 2x, I'm just gonna rewrite this one, plus 3 times what? 6x. Y is the same as 6x, so we're gonna substitute that, and then it equals -20. Okay, now we simplify that. 2x plus 18x equals -20. Simplify again. 2x plus 18x is what? 20x. 2 plus 18, so 20 times x equals -20. And then what's your last step? Divide by 20. So -20 divided by 20 is what? Something over itself is 1, right? But this is a negative over a positive, so it's a -1. Are we done? No. Here's the thing. There's absolutely an easier place to plug this one in. Which one is it? The first equation or the second equation? The first equation. If y is equal to 6 times x and x is -1, then you just drop in that -1. So y is -6. Okay. What point is your answer? -1, -6. Okay. Okay. Look at number 3. We're not going to solve this one. We're just going to mark it up a little bit. Do you have an isolated variable? Your y is isolated. So this y equals x plus 9. That x plus 9 is what's going to get put somewhere. Where is it going to get put? In place of the y down here. Okay, we're not going to solve that right now, but I just want you to see it. This one, number 4, do you have an isolated variable? Your x is isolated now. I know what x equals. I know x is the same as 4y plus 7. Where is that 4y plus 7 going to go? Right behind the 2 to replace the x. Now here's the deal. The x goes away because this is equal to x, so take the x out, put that in. Okay? Again, we're not going to do that right now, but just so you're seeing where it goes. Okay, jump to number 5. This looks a little different. Do you have an isolated variable? No, there is no variable that is completely by itself right now. But now look at all your variables. You have 2x, y, 5x, and 3y. One of those four is the easiest one to isolate right now. Which one is it? The y. Because it has a coefficient of 1. Do you know what a coefficient is? It's the number that comes in front of the variable. So if there is a 1 in front, that's the one to isolate. That's going to be the easiest one to work with, okay? So this one has that. So we're going to work with this equation to isolate my y, okay? So I'm just going to rewrite it here so we have some room to work. You don't have to rewrite it if you don't want to. What can I do to get y by itself? Subtract what? Not the 1.
2.
Well, you could subtract y, but then you have more work to do at the end. But that's not wrong. It's just not the best move. If I want y to be all by itself on the left, what do I have to get rid of on the left? 2x. How do I get rid of that 2x right now? You subtract it, okay? So I'm going to go like this. I'm going to go minus 2x and minus 2x. This is gone. So now I have y equals. Now here's where you have to be careful. You have negative 2 and a negative 2x. Can you combine that right now? No, they're not like terms. So don't combine it. Just rewrite it in slope-intercept form. And if we're going to write this in slope-intercept, I'm going to put the negative 2x first and then the minus 2. If you do it the other way, it's not wrong. I just like slope-intercept form a lot better. So now we're looking at this, okay? Ditch the fact that we had 2x plus 1 equals 2. We're not going to use this one now, okay? We're going to use this equation, and we're going to use this equation. Those are our two new equations. Do you have an isolated variable? Yeah, that's what we just did with the purple, okay? So I know what y equals. Where can I put negative 2x minus 2? It can substitute for what? It can substitute for y. So where is there a y that I could plug it in for so that there is no more y's? That second equation, that right here. So it's going to look like this, okay? It's 5x plus 3 times, and now here's where your y value goes in, negative 2x minus 2. And what does that equal? A negative 8. Does everyone see that? So I took out the y, and I put in what I know what y equals. Okay. Now you do the algebra. What's your first move? Distribute. We're going to take that 3, and we're going to multiply it by both of these. Okay, so it's going to be 5x. 3 times a negative 2x is a negative 6x. You can write plus a negative, or you can just write minus 6x. And then 3 times a negative 2 is a negative 6 equals negative 8. Now you can combine like terms. 5x minus 6x is what? That's 5 minus 6. Negative 1x minus 6 equals negative 8. Then we're going to add our 6. So you get a negative 1x equals a negative 2. And then your last move is divide by negative 1. And you get x equals 2. Are we done? Not quite. Okay, now here's the deal. I crossed out that first equation up here because I didn't want you using it anymore. If at this point you want to go back and use it again, you can, but there's an easier one to plug it into. Do you see an easier equation to plug our x into? Green or purple?
Green.
You can plug it into green. It's going to require more algebra, more moving things around. Look at purple. Purple has y by itself, and that's what we're trying to solve for. So if I just take my x value and drop it in, then y is equal to negative 2 times 2 minus 2. Negative 2 times 2 is negative 4 minus 2. So y is negative 6. Okay, so there's usually an easiest one to plug it into. Try to plug it into that one. Okay, you can do it the other way. It'll work the other way. It's just going to be more work. So your answer is 2, negative 6. Questions? Okay, here's what we're going to do. So yeah, try number 7, try number 9, and then try number 4. And I'm going to come around and just see how things are going. I'm going to tell you, well, no, I'm not. I'm not going to tell you the answer. We'll go over it in a minute. You're probably not done yet, and that's totally fine. But maybe you're done with number 7 at this point. And if you're not, that's okay. Just do this along with us just to make sure we're getting it. I saw some of you did this correct, and some of you maybe weren't sure what to do as your first step. What should your first step be on number 7? Get x by itself. So this is the guy we want to isolate, which means we're going to subtract 5y on both sides. So now it's x equals, and again, I like to put the variable first, so I'm going to call it negative 5y plus 4. If you left it as 4 minus 5y, it's okay. That's not wrong. I like slope-intercept form, and that's a little more slope-intercept form-esque. Okay, so I know what x equals. X equals negative 5y plus 4. What do I do with that? Where does this go? Behind the 3, in place of the x. So it's going to be 3 times, and now we'll plug in the negative 5y plus 4. And then it's plus 15y. So we're just going to finish out this equation. Equals negative 1. Okay, next move, distribute. So it's going to be negative 15y plus 12, right? 3 times 4 plus 15y equals negative 1. Do you see what happens in your next move? What happens? Not y. So it's
you gotta subtract.
It's a negative 15y plus 15y. What does that equal? 0y. What is 0y?
Just 4.
0. It's gone, right? It just got rid of it for us. So this goes away, and you end up with this. 12 equals negative 1. We lost our variables. On problems like this, if you lose your variable, it's one of two things. It is no solution, or it is infinitely many solutions. Kind of like we did with the graphing, right? It's parallel lines, or it's the same line. What do you think this one is? No solution. This is not true. So this is going to be no solution, okay? The way she'll write it in her answer key will be that. It's the circle with the slash through it. You may write the words no solution every single time. That's fine. But just know that when you're checking your homework, it's going to look like that. Okay? Did anyone get to number 9? What was it? 0 and 18. I wonder if you forgot to distribute your 3 to the 18? Did you get 54 equals 54?
Yeah.
That's your final answer. That's where you're done. Because the 6x and the 6x, they go away. Did you get 6x minus 6x? Oh, and then you moved it and made it 0 and divided and got 0. Yeah. So your 54s are both positive. So if you, yeah, you end up with, I know what you did. Okay, let's walk through this. So this one, I would take away the 2x. So you get y equals negative 2x plus 18. Okay, and now that, where are you going to substitute that negative 2x plus 18? Where are you going to put that? Behind the 3. That's going to go right here. So it's going to be 6x plus 3 times negative 2x plus 18 is what we're going to drop in for y equals 54. Okay, and now from here, we're gonna distribute. So it's gonna be 6x minus 6x, because it's 3 and negative 2, and then plus 54 equals 54. And now look at this. 6x minus 6x is what? 0. It goes away. So that is 0, and you're left with 54 equals 54. So we lost all our variables. There's no variable left. Is that a true statement? Yes. So your answer is either the symbol, or you can say infinitely many solutions. I'm also fine with you writing IMS if you want infinitely many solutions. That's fine too. Okay, so if your variables go away, it's either infinitely many or no solution. Okay? Questions on that? Okay. If you want to try one more, you can try number 4, and then I'll come around and check it for you. Or if you want to just get started on the homework, you can get started on the homework. We're doing 2 days of this because this is a little tricky, figuring out how it all lays out.